This session is on PODS, Mack Truck's digitalization building block. In this session, we're going to talk about what it means to be digitalized, some of the steps and capabilities you need to be digitalized, how the POD system is an example of a digitalization building block, and some of the best practices you could follow to become digitalized yourself. So we'll talk about digitalization, the many points of view. There's often a business point of view and an IT point of view, and sometimes they get confused. We'll talk about the Mack data pods as a building block and the digital future. My name is Shawn Fitzgerald. I'm a business information architect and enterprise architect with Mack Trucks here in Greensboro, North Carolina. I've been in IT for 25 years in several different companies, from startups to national and global corporations. I've been with Mack Trucks for a couple of years now as a consultant and as a full-time employee. About the last 10 years, I've been in enterprise architecture, and that is where my passion lies. The intended audience for this presentation is anybody that has a digitalization strategy and needs to execute on that strategy, whether you're an IT staffer or you're a business staffer. Some of the things you should take away from this is that digital business outcomes are built on digital IT outcomes. The key capabilities and tooling needed to digitalize your journey, and also understanding why we at Mack feel like PODS is a digitalization building block. And lastly, we'll talk about digitalization as the end game for all modern enterprises. So in digitalization, you've probably heard a lot of different points of view. Most of them come from the business point of view. But in this session, I'd like to make sure that we keep the business point of view and the IT point of view separated. It's crucial to a successful digital transformation. So first, let's start with a digitalization definition, just a level set. The Oxford Dictionary says the conversion of text, pictures, or sound into a digital form that can be processed by a computer. For us in IT and business, this generally means we're going to automate a business process and the data entities, the inputs and outputs of that process. A lot of our information about digitalization comes from consultancies. Not real surprising there. McKinsey looks at digitalization as a means of being closely attuned to how customers' decision journeys are evolving in the broadest sense. At the bottom of this slide, you can see the Mack customer journey. It starts with the customer discovering the product, ordering the product, receiving delivery, using the product, and then ultimately selling or trading that product off. But if you look at that journey map, there's really nothing around IT or technology in it, which makes it kind of difficult for the technologist to determine exactly what it is they're having to produce. Gartner gets a little closer. Gartner's pretty good about creating their own vernacular around these things. So for Gartner, digitalization is a connection. It's a connection of resources to create something they call a digital being. I like to think of it more as a digital presence because digital being's kind of spooky. But it's something that you can engage digitally or discover and engage digitally. You do this through one or more what they call digital interactions. Maybe these are the digital channels we've talked of in the past, but it could be one or more devices, one or more web applications or systems that you would access digitally. Lastly are the digital operations. These are the things that deliver and support and seamlessly connect all your interactions to create that digital presence that you've discovered and you're interacting with. All of this to achieve the desired business outcomes. First, the business outcomes, those are the things that are going to make up your digital presence, your digital being, and your digital interactions with your customer and your systems. So some of the things in business you'll hear very frequently is this visibility into the end-to-end customer value journey. Exactly what are the things they're doing? What are the events that the customer is driving, kicking off? When are you aware of them? So we want to understand what's happening in real time so that we can leverage those events and help that customer make the right decisions for them, but also drive more decisions and more closes on sales. To do this, we need data accuracy, consistency, and availability of that data all along the value chain. We've probably all got stories where one user has switched from one system to another, and the data is either not available or it's different. Having this data that is consistent from end to end is going to give you a deeper insight into that event data. With that, you'll be able to understand your customer better, know where they're going, and perhaps give them a delightful and satisfying experience because they feel like they're known. Lastly, operational efficiency and flexibility. With the full digital stack, you start to achieve this. That gives you the ability to stay attuned to your customers and therefore your market and stay relevant within that market. And of course, that drives you to a healthy balance sheet at the end of the year. So that's some of the business outcomes, some of the business points of view. But again, we really, besides talking about data, mentioned much about IT. So what are the IT outcomes we're looking for? So back to the Gartner slide, the IT outcomes would be equivalent to what they mentioned are digital operations. These are the IT processes and business processes that have been automated. One thing about these processes, it doesn't do any good if you can only use them once or twice, or you can only use them in specific context. You want your processes to be repeatable and idempotent, meaning that whatever goes into it, you always get the same result as long as those inputs are the same. Obviously, you need the data synchronized end-to-end, very similar to the business, but for different reasons. For data quality, for being able to audit and evaluate your performance. Data consistently traverses all devices and channels, meaning that if I ask for data on, say, my vehicle through a mobile app that I as a customer may have, I will see the same data there as if I had gone to perhaps a dealer portal or an aftermarket supplier. We also want predictive and prescriptive capabilities as well. We want to understand these real-time events, but for, again, different reasons. Not as much for the customer delight, but as for the delight of the business systems that are relying on our IT systems. So we would use predictive and prescriptive analytics to drive our infrastructure and our performance SLAs. Probably one of the best examples of this is elastic scaling on a cloud platform. Once you've digitalized your IT processes, your IT systems, you should expect your IT runtime cost to start decreasing. You should also expect to have more transparency because you're logging everything, you're analyzing everything, you know when you're having problems. In other words, the burning platforms start to go away. You may feel a little warm, but you get ahead of them and fix them before they become a real problem. The digitalization team begins to benefit from this ubiquitous digitalization process because as they move from business value chain to business value chain, they encounter the same digitalization tools, the same standards and processes. So that training for them is simply understanding the business requirements to execute on a well-known digital platform. Ultimately, once this is achieved, your enterprise becomes one unified system that's leveraged and driven by AI. So to put the two together, they seem like they're a little bit apart, but it's more like the weaving on our cloth, the warp and weft. The business processes are digitalized on and with the IT capabilities, the digitalization tools to achieve the business outcomes. The IT capabilities are digitalized not to create the business outcome, but to create the tools that yield the business outcome. So what are some of these tools that we might look at? Well, for Mack, it's this list right here was determined to be key. The IT capabilities, also known as digitalization tools, if we want to be a little more modern. The items that are in bold are ones that we've actually been able to implement with a PODS system I'll talk to you about in a moment. So first thing is very important. You got to know where you're going. You got to know what the vision is. You have to know how to set up your guardrails to make sure that all your IT activities are moving in the right business direction. So it's good to have an integrated and long-term strategy management plan or system. We won't talk about tooling. This could be anything, but as long as it's not just a document that dies on a shelf somewhere, but that stays with the development and the delivery of those digital capabilities. We need centralized data models. It's probably fairly common if you've had any experience in IT to have multiple snapshots of data, particularly customer data, that don't always stay in sync. Having a centralized data model and hopefully centralized data repositories governed with master data management, you can start to move away from a lot of these siloed transactional databases that require a tremendous amount of lifting to keep in sync. One of the things you need once you have this shared data model is shared data governance to maintain it, to make sure that business rules are applied correctly no matter where the system is. We also want to look at federated security model, meaning that my security token acquired from one system is still valid with another system, so that I do not have to continually re-authenticate and reauthorize. Sometimes this is called single sign-on, but it has other benefits besides single sign-on. Centralized service framework. All I'm saying here is standards of object-oriented programming should apply. Try to create your base classes for your services so they're consistent, so that they do the basic generic things of IT, like logging, in the same way, using the same services and patterns. You also want to have a relevant dev star ops, and I emphasize the star on this one because most of us think of DevOps as just something for the delivery team, but we could also apply DevOps to security, infrastructure, networking, and even finance if we want to stretch our imagination just a little bit. We also found that we needed low-code, no-code development for speed. Mack Trucks does not have a really large staff. We build trucks. We're a manufacturer of trucks, a retailer of trucks, and a servicer of these vehicles, heavy and medium duty. We're not really a software development company, so it'd be good for us if we had ways to develop some of our digital products and business products faster and more rapidly. So low-code, no-code is an option. Centralized policy and rules management, similar to the centralized data model, it makes sure that all the business rules and policy are applied consistently across all systems. A common integration and data access pattern. So this is rather simple. For Mack, we've decided to go all out with APIs, RESTful, and use JSON. Combine this back with our centralized data models, and we have very consistent ways to integrate with data and other platforms. The workflow engine is also a critical piece. If we're going to automate processes, it would be better to have a workflow engine that could process common workflow models, BPML, for instance, and not have to rewrite an application for every business process that you want to create. So this workflow engine can be changed. It in and of itself does not change. It is a digitalization capability that consumes the changing business processes. And lastly, a ubiquitous AI and machine learning capability. Again, this really starts with good logging, capturing of those events. So you may not have to know everything about AI or have AI completely in place, but you should start logging all of your significant events now. So how did we realize some of this, especially those highlighted items, with the Mack's data pods? Pods, by the way, not to be confused with the container pods, but we call these portable operational data services and consider them to be a digitalization building block, and I'm going to explain why. A little history, I'll go over this pretty quick in the interest of time. Volvo Mack began their API REST journey in North America pre-2017, decided to go onto the Azure platform with the API gateway. That's about the time I joined the company. We started building out our APIs, and we realized very quickly that because of our legacy systems, mainframe, back-end MQ servers, and also a manual governance process that tend to take a little time, let's put it that way. We found that accessing data sources on-premise from the cloud was rather time-consuming and even costly to a project. So we decided to come up with some other way to do that, and PODS was born as a proof of concept to simplify the data access while also lowering the overall cost of integration and the project. So in 2019, we kicked it off. By the end of the year, we had our first client on it, and they were reporting 300% improvement in performance. They saw a dramatic improvement in the quality of the data. And then the last thing that we got a pat on the back for was it took them 10% of the time to integrate than the previous project that they worked on that was very similar. So we think we hit our goals there to the point that in 2020, PODS, until the virus, of course, was becoming a rapidly adopted data access solution at Mack, and possibly to be adopted globally in our other business units. So let's look at PODS real quick. Again, it is not an application that the user interacts with directly on the front end, nor is it what we would consider a back-end system. It's in the integration layer, what we call the Mack operational backbone. So it sits there and becomes effectively a broker of master data to the systems on the front end that need it. It delivers these capabilities as we discussed, and at a high level, we can look at the architecture. Now, I won't go into a lot of detail here, mainly for the interest of time. But if you take a look at this slide, the green box on the right of the screen represents the PODS system, the Portable Operational Data Services system itself. Now, this is your low-code, no-code environment, actually. It's driven by configuration, JSON-based configuration. It's all running on Azure. We don't have any virtual machines. We don't have to manage any images. We use the native services. We've configured and tuned and secured them appropriately using Active Directory and B2C. We use OAuth tokens and JWT tokens, Java Web Tokens, for anybody that's not familiar with them. And every component of the system requires that token. So the green box, the pod system, actually is a low-code and no-code environment that generates, based on configuration, a pod solution, represented in that brown circle. It's a very simple thing. It's basically a GraphQL server. Think a REST API. If you don't know what GraphQL is, I encourage you to go out and take a look at it. It's a pretty hot technology. Behind that is a Cosmos Document DB container with the data. That is a pod solution in a nutshell. Now, that GraphQL server is different pod solution to pod solution. It has some logic for querying the database and also for securing that data that may vary from pod to pod, but that's part of the configuration. You don't have to code that. The last pieces of the pod system are the API gateway, which again is decoupled. It's in this box just to show that it is there and leveraged. You could conceivably hit a pod directly if you needed to. And the other piece of this overall system is the event subsystem. So we use Azure Event Grid. So if there's a data changes, you can subscribe to data change events, and that data will be pushed to you if you can provide a webhook. Or if you don't want a webhook, if you want to just pull the data, you can go straight to the API with a request reply. One thing I do want to point out on this before we leave this slide is some of the consumers of a pod are other pods. So pods can reference each other and be chained, and we'll talk about that in a little while. So again, I said it's a declarative system. It's configuration driven. The configuration is a JSON, what we call a metadata file, an MDF. And in that is the schema of the master data system, the schema of the output, which could vary a little bit, that's coming out of the GraphQL endpoint, some security settings. You can create security groups and apply that security group not only to the pod, but down to the record and column of the database. And that is completely self-service. The owner of the pod, the owner of that data, can change these on a daily basis simply using the intake API and the MDF file, no code needed. So once you have your MDF in place, you simply push it to the intake API, which is a REST endpoint backed by a GraphQL server. It breaks down the MDF, generates the code necessary for the GraphQL server, deploys the container, pod container, and sets up all the other security configuration that's necessary. And there's your pod. Once you have your pod built, it's the same process almost to populate data into it. The intake API also has an endpoint for, a GraphQL endpoint for accepting data. The pod system will take the schema that it had from the original MDF, validate the JSON data, and push it out to the Cosmos Document DB, where it's available for the consumers who are authorized to see it. So altogether, the PODS, Portable Operational Data Service, is a highly decoupled system that's based on the PODS system to generate various pods that exist, again, decoupled from each other, but can, through the API and the GraphQL endpoints, reference each other. So the pod consumer, again, either go through the API gateway, make the calls they want on that pod, or they can sit back and wait for synchronization events to occur and receive that data through a webhook. We also have a UI. Consider this a service catalog, not necessarily a registry since it's not machine discoverable. But if I was interested in accessing data for a specific project, I can come out to the pod service catalog, see what data is available through a pod. It will list out all the entire schema of that pod, all the queries, the authorization that you need to have. And if it looks like it's what you want, you simply hit the subscribe button. A notification is sent to the pod owner. When they accept that, it automatically will update this system and add you as a user. You'll get a notification later from us as the PODS team. We don't want this to be 100% automated. We do a little validation to make sure that you can connect and that you are the right person connecting. So PODS has a couple of superpowers, well, what I like to call superpowers. And one of those is the ability to chain pods. This comes from two things about the architecture. One is the fact that all the components are loosely coupled and fronted by APIs, so it's natural that I can connect them via these APIs. One of the other things, and I guess that's the self-referencing part of the building block. I could have one pod call another pod to get certain data to augment a query or a request made by a consumer. We actually have at least one of those pods out there right now. We call those the app pods, which are the ones in blue, as opposed to an entity pod, which is strictly the entity master data. So you can combine these through API calls, but GraphQL also supports something called schema chaining. So if you remember, every pod has to have a schema to define the data that is hosted in that pod. Well, GraphQL allows you to combine them so that I could have 5, 6, 10, 100 of these pods, but only need one pod to enter it, so that I could see all my data, whether it's vehicle, customer, dealer, fleet, or part data, all in one place. So no more nightmare of 500 endpoints I have to manage. We can do it with one. Another superpower that PODS has is the fact that we keep business rules out. It is very generic. We push the business rules to the edge, to the systems that are consuming that data, so that if those rules change, it does not impact that pod. It does not impact the data access for other users. So we are basically, what we're doing is we're preventing silos, trying to break those down so that we become more and more a single unified entity. So the business rules can change without you requiring an entire update to the entire system. In other words, pieces conversion independent of others. Normally these changes are low impact and low risk because we are built basically on the master data schema and some very basic queries that come off of that. So we don't embed the business logic, so if there's a change to business logic, it occurs outside of the pod so that there's a low impact on anybody else. And the last thing I wanted to point out, PODS is not an application. It's not a solution. It is a tool to be used by other applications and other solutions to deliver their desired business outcomes. Most of the digital building blocks that you might be creating are not applications or solutions for the business. They are just like PODS. They are used to build those solutions and business outcomes. So we'll take it up just a little bit more abstract here. Because it's self-referencing and because I have an eventing system in it, I can go through some very simple workflow. Again, I emphasize the word simple. It's not a workflow engine per se, but it can execute some workflow based upon event rules, based upon changes to the data specifically. So in this example, that internal system that's down at the bottom bottom left of the screen, perhaps they update a vehicle, let's say a vehicle delivery date. They use a generic business service to update the master data system, which in turn sends that delta to the pod. Most of our pods work on deltas, so as data changes in near real time, we are updated immediately. Once the vehicle pod gets that data, it runs its event handler. The event handler says, oh, I've got this system over here that's subscribed to it. In this case, it's a mobile application. And I send that mobile application, hey, the delivery date of this vehicle has changed. So that person gets notified of it, but I can notify other systems. I could update the original system and tell them, we got your message, it's been updated, you're good. So very simple workflow, all based upon data change events. So that's where PODS is now. The future is much bigger than this. PODS is a very small piece of digitalization. So I want to talk just briefly, in the last few minutes we have, about the digital future. So the ultimate goal of digitalization, and this is my opinion, is that we are trying to build strategically controlled, event-driven, and a fully automated enterprise, where IT functions are indistinguishable from business functions. They operate together. IT and business are the same unit, no more us and them. Strategy realignments occur across the enterprise in real time. I suspect these will be incremental changes. Perhaps because a virus is struck, we may need to change our strategy. Instead of having to spend months to determine what that is and how are we going to get it out there, these systems are able to be tweaked incrementally at runtime to achieve those strategy changes. To do this, we need to be off small and large-scale decision-making must occur at superhuman scale. Think of your competitor. If they are operating with AI across vast amounts of data, and you are still pushing paper or spreadsheets, they are probably going to make better decisions faster than you and end up taking your market share. So digitalization is almost an imperative at this point. Once we've reached this superhuman scale of decision making, we are starting to get into that real digital being that Gartner talked about, where your entities, your business entities, become self-aware and federated. They communicate with each other without any human intervention. And eventually what you have is digital life analogs begin to emerge. Some of them are already emerging. Autonomous vehicles, for one. Mack and Volvo have autonomous vehicles they're working on. But also business systems. Consider an HR system and a finance system that can communicate together and adjust staffing based upon finances and not have to wait every quarter. So what would something like this look like? So this is just I don't know, maybe a pie in the sky. But this enterprise reference architecture shows, well, leadership, your strategy developers, they come up with a strategy, the strategic objectives and goals they want to hit. Hopefully they're reasonable, hopefully they're measurable. These should be driven down mainly by the senior VPs and VPs into the various business areas, into the business capabilities. What are the changes that have to be made? That should translate into backlogs for each of those capabilities that then translate into the services, the APIs, the applications and systems on the other end. These are used to gather data. That data is analyzed. And from this, predictive and prescriptive recommendations are made back to the leadership team who adjust the strategy, the strategic objectives, therefore the capabilities, etc. ad infinitum. All of this run at the bottom layer by an integrated DevOps capability. Simply put, it's a business value engine that never turns off. So there's some recommended next steps. You got to have a good strategy. You got to know what your business outcomes are. The second one's really key. Make sure you separate your business outcomes from your IT outcomes, but keep them as equal value. Begin with a small value chain, but one that represents your entire business model as best it can, so you don't get surprised later on. Keep all your IT capabilities generic, reuse in other words. Organize around capabilities and backlogs. Do not organize around projects and applications. They go away, usually on a yearly basis, but your capabilities and your backlog will remain. Resist technical debt. There's not a good reason to do it. There never really is. Sometimes it happens, but minimize it. And if nothing else, do what you've always known as an IT engineer, as a project manager, as a business manager, and you will be okay. But the thing you have to do is apply your knowledge for real-time AI at scale and speed, something that may not be familiar to you. Last, digital transformation is a full transformation. It has to be driven top-down by the business and delivered bottom-up by IT and your business partners. Everyone has to participate. So this last slide here, it's a nice sentiment. May the road rise up to meet you. May the wind always be at your back. But isn't that what digitalization is about? Bring the customer's journey to them. Make sure that they move down that path in a way that satisfies them and brings them to a good decision for everyone. If you have any questions, feel free to contact me, shawn.fitzgerald@volvo.com, or on my LinkedIn account, linkedin.com/n/ESFITS. Thank you very much, and have a great and safe day.